Hey guys, welcome to week 6. I'm sad that this is not happening in class because this is one of my favorite topics to do with you guys at the end of the year. So we're going to start talking about statistics. Statistics is very interesting because it's very real world oriented and we can do so many different things, look at so much different data with these different types of graphs and plots that we're going to look at during this week and next week and almost to the end of the year. So statistics is the science of collecting, organizing, and analyzing data. There's so many different types of data we can collect, ways we can organize it, and ways we can analyze. So when we talk about data, it's broken into two main categories. Categorical data, obviously categories. So when we're talking about categories, we're talking about what's your favorite color, what's your favorite animal. We're talking about putting people in categories based on things, not necessarily numbers of things. So quantitative is the opposite. So we're talking about numerical. So how many brothers and sisters do you have? I have one. How tall are you? I'm 5'6". So quantitative is talking about numbers. Categorical is obviously talking about categories or words or things. So underneath quantitative, there's two different types of data. There's discrete data where there's only a specific number of values. So for example, how many siblings do you have? I have one, I have two, I have three. Those would be discrete. And then an example of continuous would be, for example, distance. So you could break distance into miles, half a mile, quarter mile, eighth of a mile, 0.0001 miles. So there are too many possible data values to be able to plot them individually. So that's when we want to talk about continuous data. So here's some examples, and we want to classify them as either categorical, discrete, quantitative, or continuous quantitative. So if you're talking about height, there are so many different heights that you could be. Not everybody is like 5'6", 5'7", 5'8". You could be 5'6" and a half, 5'6" and a quarter, 5'6" and an eighth. So we're going to qualify that as continuous quantitative because it would be more helpful if we separated that into intervals. Favorite subject. So those aren't numbers. Favorite subject would be math, science, social studies, language arts, art, PE, chorus, and so on. So we're going to consider that categorical. Number of televisions in a household. This could be classified by only whole numbers. 1 television, 0, 2, 3, 4. So that would be discrete. Your area code. Although your area code is a number, you are not telling me how many area codes you have. So technically this would be categorical because your area code is going to put you in a specific category. We're not asking how many area codes are there. We're asking what is the area code. Distance of football is thrown. I kind of talked about distance already. That would be continuous because there's so many different numbered distances you could have. And then the last one is number of siblings. Obviously, that would be discrete because you can only have whole numbered siblings or none. So here's a plot. This is called a dot plot. And obviously, it's called a dot plot because above the numbers, there's as many dots as there are data. So a group of college students were surveyed at the number of books they read each month. And here's the list of data. 1, 2, 2, 2, 3, 3, 3, 3, 3, 4, 4, and so on and so forth. So you'll notice in the data itself, there's 1, 1. So that's why I put a point, 1 point over 1. There's 3 2s. So that's where there's 3 dots. 4 3s would be 4 above 3, 5 above 4, and so on and so forth. So this dot plot represents the number of books they read each month. Each data value is represented with a dot above a number line. The dot plot shows the frequency of data values. Always, when we make a dot plot, we always want to include a title and then some sort of scale. Dot plots are often used for like a smaller amount of data because we don't want to be drawing hundreds of dots on a dot plot, and also discrete. Notice that these are specific whole numbered items. It would be kind of hard to draw a dot plot for like distance or money or something of that. So what is frequency? Frequency is how often the data is occurring. How often data occurs. So if we look at this oops, URS. Well, let me fix that. That is not very pretty. If we look at this dot plot, if we wanted to know how many people read 5 books, we would look at 5 and count the number of dots. 4 would be the frequency of people that read 5 books. So here's an example. So the amount of time 26 students spent on their phones on a given day, rounded to the nearest hour, is recorded as follows. So we're going to create a dot plot. So let's title it. So title it time on phone. So we're going to dot number 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and it looks like 12 is the largest. All right, so let's just start creating the dot plot. So 0 has 1 dot. 1 and 2 aren't listed in the data. 3 has a dot. 4 has 2. 5 also has 2. 6 has 3. 7 has 4. 8 has 4. 9 has 3. 10 has 3. 11 has 2. And 12 has 1. So that would be the dot plot for this data. Obviously, it makes the information a little bit more organized for us to tell instead of having to look at this like long string of numbers here. So let's create another one. So Mrs. Ferrante surveyed her class and asked each student, how many siblings do you have? And here's the results. So construct a dot plot of the data. So we'll start with 0, and it looks like 8 is the biggest number. So zeros, I see 1, 2, 3. So we'll have 3 dots above 0. 1, I see 1, 2, 3, 4 ones. 2s, 1, 2, 3, 4, 5. 3s, 1, 2, 3 threes. 2 4s. And then 1 8. Wow, I can't imagine. So what observations can you make about the shape of this dot plot? So it looks pretty much like most of the data is clumped together over here. So most data is clumped. And then there's this one value far away. And then the second question is, are there any values that don't seem to fit? Obviously that 8 doesn't seem to fit. And you may have heard this word in the past, but that's called an outlier. Outlier means that you have a data set, a piece of data that doesn't really match the rest of the trend of the rest of the data. So 8 obviously isn't a very common number of siblings, but in this case, in this class, someone had 8. So that would be the part of the data that doesn't really fit. It's called the outlier. All right, so the cafeteria at Just Dance Academy offers items at 7 different prices, and here's the dot plot of those items that they sold in 2 hours. So describe the data from the dot plot. So the first thing I would say is most people bought $3. Bought $3 items. Another thing that may be important for this group to know is how many items did they sell. And that would mean we'd have to count the dots. If you sat and counted these dots, it would be 24 items sold. You could also calculate the total number of items. And here you would have to add up the prices of all of it. So that's another way you could describe this dot plot. All right, let me know if y'all have questions, and I look forward to hearing from you guys. See you later.